Here's our unit notes for the quadrilateral properties. So we're starting with lesson 8.2, how to use the properties of parallelograms. And in this unit, we're just going to be doing a lot of different vocabulary and theorems, and we're just going to kick it off with what a parallelogram is. So it says a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So let's underline that. Both pairs of opposite sides parallel. And it's important to know some key facts when looking at that. So the first one is, it says the term parallelogram can be written as this, using the symbol. And you will see this symbol right here, which are two lines going up and down. Those two lines stand for parallel. So if I see the line PQ, which I see right here, is parallel to the line RS, which is right here, you will see this symbol when it's being written out, but you will also see the same amount of arrows actually on the shape. So if we check it out again, I'm seeing right here the side QR, so here's QR, and the side PS, they have two arrows as opposed to just the one, and that's telling me that they are parallel to each other. Okay, so moving on to theorem 8.3, it says a quadrilateral is a parallelogram, then its opposite sides are congruent. So let's look at some key symbols here. I am seeing that it says PQ, side PQ, and then I see it kind of printed, not super great, but there's the congruent symbol, which just means that PQ and RS are the same length, right? How we recognize that is we have the dash symbol showing that they are congruent. And if you look on the opposite side, so QR and PS, there is two tick marks here and two tick marks there. So that is showing me that those sides are also congruent. So we see that for a parallelogram, the sides are parallel to each other as well as the opposite sides are congruent. So let's move on to theorem 8.4. If a quadrilateral is a parallelogram, then its opposite angles are congruent. And so let's see what this means in terms of symbols. I'm seeing angle P is congruent to angle R. So here is angle P, here is angle R. We notice that they are opposite of each other, so they're in like opposite corners of the shape as each other. And I'm seeing there are two like loops on each angle, and that's telling me that they equal the same thing. And if I check out the other angles, angle Q and angle S, I see angle Q has one loop and angle S has one loop, meaning they are going to be the same. Okay, so when we get into some of the practice examples on the bottom of the page, we're going to use some of these facts to solve it. So it says find the values of x and y. I'm going to start with the angle because I see angle A is y, angle C is 65 degrees, so I can very simply say y equals 65 degrees, right? Because I know opposite angles equal the same thing. They are congruent. So that was very easy. Next, we will deal with the sides. I see side AB and side DC. They are opposite from each other. So in a parallelogram, that means that they are congruent. So I'm going to add in my little congruent tick marks. So let me set up an equation. X plus y, that side, equals 12. Because again, I know that they are congruent. Doing a little bit of algebra, I know that if I subtract 4 on both sides, I will be left with x on the left equals 8 on the right, and that concludes the question. I got x and y. X is 8 and y is 65 degrees. All right, moving on to question number 2, example number 2. Let's start with the angles, just like how we started with the angles last time. I see angle J is 2x, angle L is 50. They are opposite angles, so I can create an equation. 2x equals 50. They are congruent, so they are equal to each other. I can make a little algebraic equation. And I'm just going to divide both sides by 2, because instead of having 2x, if I divide by 2, I will be left with just an x, and 50 divided by 2 is going to give me 25. So x is 25, and we get into the sides. I see side KJ, I see side LM. They are going to be congruent because they are opposite sides of a parallelogram, so they equal the same thing. So setting up an equation, y plus 3 equals 18, and looks like all that I need to do is just subtract 3 on both sides, which gives me y equals 15. And that's my answer. So let's go ahead and flip the page. We got a couple more theorems, 2 more theorems to go, and 1 more example. Okay. So theorem 8.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now, consecutive angles, they're the kind of, you could think of them as the opposite as like when we were saying opposite angles. They do have a theorem here, or an equation here to kind of help us visualize what that means. So consecutive angles, if I'm talking about angle P, what I learned on the last page is that angle P is actually congruent to angle R. Consecutive means they're not opposite each other. They're actually like in a way kind of next to each other, right? They're connected by a side. You can kind of think of these as being next to each other. And if I were to add these 2 things up, they would give you 180. So let's like visualize this as an example. If I say that x is 100 degrees, I know that that would make angle Q 100, and that would also make angle S 100. Now, if I know that angle Q and angle S are both 100, what that means is that angle P is going to be 80. And also, angle R is going to be 80. Because as this theorem says, the consecutive angles, the angles that are kind of like connected by a side right next to each other, when you add them together, they should equal 180. And so this is an example with some numbers of what that means. Okay, theorem 8.6, if a quadrilateral is a parallelogram, then the diagonals bisect each other. And just in case you don't know what bisect means, it's kind of like dissect. Bisect means to cut in half. Think about bi as in 2, sect as in cutting. So bisect means to cut in half. So the diagonals that you draw from one angle to the opposite angle, this line is going to cut in half this line, this diagonal. And so if you actually see how they've kind of written it here, they say QM is congruent to SM. So we see M is right in the middle. Q to M is congruent to S to M. And the way that we see it in the shape is with the tick marks. And same exact thing, P to M. So again, M right in the center. P to M is congruent to R to M. And we have 2 dash marks because we don't, honestly, it kind of looks like PM is going to be a longer length than QM. So we can't say that these are going to be congruent. I just can say that with the diagonal, it's getting cut in half, and those 2 halves are going to be congruent. Okay? So with this lesson, we just have one more practice problem, and the practice problem is giving us a bunch of angles and sides in this parallelogram, and it's asking us just to find kind of some of the specific pieces. And so the only stuff that I see is given to me is a 2, a 110 degrees, and a 30 degrees. So we're going to use these to help figure it out. So let's start with NM. this is a length, this is one of the sides. Actually, I'm noticing it's one of the diagonals, right? So not even one of the sides, it's one of the diagonals inside the shape. And so I am remembering that in a parallelogram, the diagonals are bisected, right? So I know this side of the diagonal and this side of the diagonal, they will be congruent. So if this side is 2, then that means that is 2. So the first one equals 2. Next, I see Km. So I find K, I find M, and I need to figure out what this length equals. Luckily, by finding NM, I know Kn is 2, NM is 2, so Km is 4. Okay. Next, I'm seeing some angle symbols, so we're getting into some angles. So I'm guessing we're going to need 110 and 30 in some kind of way. First step, it goes from J to M to L. So J to M to L. So I am trying to figure out what this angle is right here. I notice that I have 30 degrees, right? Unfortunately, this angle is 30 plus some other piece that I don't really know. I got to figure out what this is in order to figure out what the whole thing is. Now, what I'm going to keep in mind is the consecutive angles theorem, right? The one that was on top of this page, 8.5. If I know that this angle is 110, then of course I would know that this angle right here would also be 110. But 110 and this angle have their own special relationship. I know, let me pick a different color. I know that these two angles added together should equal 180. Okay? When I add these two angles together, they should equal 180. So perhaps a good first step would be, let's take this 110 and subtract it away from 180. And that's going to give me 70 degrees. So I know JML, this blue angle in the corner, the whole thing needs to be 70 degrees. Because if this is 110 and this is 70 degrees, when I add them together, they will equal 180. All right, so JML, we figured it out. It is 70 degrees. And then finally, our last one is KML. So KML. K is up here, M is here, and then L is here. So we are looking for this angle right here. This one right here. And since we just figured out that the whole thing, this whole corner is 70 degrees, and I know this little piece is 30, then this has no choice but to be 40 degrees. Okay, and there's our answer. Using a bunch of colors helps me in like organizing problems like these, so maybe pick up some color pencils and use that to keep yourself organized. But that concludes the notes. You are good to move on to the practice problems. Good luck.